All right, here we go. So, number 9. The first step to number 9 is obviously we just want to solve for the intersect. Okay? We want to find the intersection. We want to know, are these lines parallel? Or do they intersect? Okay? If they intersect, we want to know where they intersect. Once we know that, when we graph them and we see where they intersect, that intersection should match what we calculated. Okay? So this is a nice way to figure it all out. The one thing you have to understand with inequalities is when they have equal to, right, less than equal to, greater than equal to, they are solid lines. Okay? If they are just greater than or less than, they are dotted lines. Okay? And those are that's like the most important thing you need to know. Okay? It's just like they have a hole when it's greater than, they are solid dot when it's equal to, same thing. Okay? Alright, so let's go about finding this intersect. So what's the first step? We want to get rid of a variable, right? So which variable is easier to do? X and X or negative Y and 3? X and X. Yeah, and for me, personally, I would change the top. Why would I change the top? Anybody remember the first problem we did in here? Why would I change the top if I have a choice? Because I get to write it right underneath. Then I don't have to write both equations again. I'm lazy. Okay? I'm lazy. So all I'm really doing with the negative is changing the values. They're either the value of a negative becomes positive or the value of a positive becomes negative. That's it. All the way through. Okay? Now, if I multiply by a negative, what happens to the symbol?
Isn't it
Yes. So the symbol will flip if I multiply by a negative. Okay? So we have to remember that. Next. So what did I do? What's that called in here? That's PEMDAS, right? No. That's SADMET, right? Both sides. Two sides. So it's actually DM, right? With the arrow at the bottom. Okay? And then I add these two equations up, the x's cancel, and I get negative 4y. And then this, it really just doesn't really matter because it doesn't happen anymore, so we're just going to call equals. Okay? And then this becomes negative 8. Okay? Now, how do I solve?
You divide negative 4.
Okay? And again, that's just, oops, that is just DM, right? Okay? So we know y is 2. What can I do from there? So Robert, what do I do from here? Please put your phone away.
We will from there.
Pearl, what do we do from here? Substitution. Yes. Okay. So which one do you want to sub it in?
I really wish I knew the answer.
You want the top one or the bottom one?
The bottom one.
Okay. Yeah, the bottom one has less numbers, right? So it's kind of a nice one to sub it in. So this is x minus 2, right? Because y is 2, is greater than equal to, or greater than 1. Okay? Now, once we start doing this, it's really just going to turn into an equals. Okay? So do the opposite of minus 2, so that's plus 2, right? Oh, by the way, that was substitution, right? And then we're going to add 2, so we get x is equal to 3. That's SA, right? Because we added on both sides. All right, so we know where the intersection is. Where is the intersection? Oh, we never said what happened here. How did we combine these?
Yeah. No.
Besides DM. DM is what I did when I multiplied it through, right?
Yes.
But then when I added them, remember that was the definition of linear combination. Good job. Why did that come to my mind? What is this one?
That's different.
Definition
System
of
equation.
systems of equations. Good. I like it. Okay. And what is my intersection? 3 and 2, right? 3, 2 is my intersection. X, Y, okay? So now let's graph them, all right? Now, graphing is a little bit different, okay? There's a couple ways we can graph, right? Remember back in chapter 4, we can plug in 0 for X, 0 for Y, and solve, okay? So let's do that with the first equation. So we have X plus 3Y is greater than or equal to 9. Now, if I plug in a 0 for X, what is Y? So that goes away. I divide by 3, right? So 9 divided by 3 is what? 3? Good. Okay? All right, then I plug in a 0 for Y, okay? And X is equal to 9, right? So that's a great way to start the graph. So we got 0, 3, 0, and 1, 2, 3, right? And we have 9, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? 9, 0. And that's your graph. Now, is this graph dotted or solid? Is this line dotted or solid? Solid, good. Okay, so we're just going to go like this. Now, here's the big question. Do we shade it up or do we shade it down?
Shade it down.
Down, 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 very good. No.
Oh.
What's it say right here?
Oh. Equal to or greater than?
Greater than. Now, if the y is negative, we would do the opposite. Okay? That's one thing. Remember, if the y
Oh, you told us.
is negative, right? Do the opposite. Okay? So, whatever this says, I'm going to do. It says greater than, I'm going to go greater than. I'm going to put my pin on the line, and I'm going to go greater than. Does that make sense? Now, if the y is negative, then I do the opposite. That would be less than, right? Okay? Now, that's one way to graph. What's the other way to graph? Let's take this one. X minus y is greater than 1, okay? So, this is graphed through substitution. Now if I subtract x, I get negative y is greater than negative x plus 1. Now, remember how I said if the y is negative, you do the opposite? And this is why. Because when I solve for this, I have to divide by 1, negative 1, right? Which means everything is divided by negative 1, right? So all the signs change. That means the sign flips, right? So we get y is less than x minus 1. Okay? So this is the definition of slope intercept form, okay? Slope intercept form. Or what we like to call y equals mx plus b, right? In this case, what is b? B equals negative 1, right? That's b. That means that's where my starting point is. And what's my slope? My slope is 1, right? That's my m. Okay? So my slope equals 1 over 1. It's a positive slope. So that means I go up 1 over 1, up 1 over 1, right? So I'm going like this. Now, did I cross at 3, 2? At 1, 2, 3, 1, 2. Is that where I cross? Is that the intersection? Right? The intersection is at 3, 2. Now, is this line solid or dotted? Does this mean solid or does this mean dotted?
Dotted.
Dotted. Good. So that means go in here and make sure you erase, right? And get the dots in there. Okay? Does that make sense? Now, are we going to shave it up or down?
Down.
Well, it says down, right? Okay? Now up here it said up, but this was opposite, right?
Yeah.
So we know down. So even if you threw in the zeros, right? Okay, so we're going to go up, right? Double checking. All right, now, what does that mean? Okay, now this is what is really crucial. This, right up here, right in here, this is where all your answers lie. All your answers for both equations are up here. Where are none of your answers?
Down.
Down here. So anything down here doesn't work. Anything up here does work. Okay? And that's how we deal with the systems of equations. Questions? It's a lot of work. This is basically everything you've done this whole year, all put into into two equations technically. Okay? And then trying to be able to graph them. Now, I'm going to call you out. Colise, I don't see you working. I don't see you taking notes. Josh, I don't see you taking notes. Eddie, I don't see you taking notes. Blaze, I don't see you taking notes. Robert, I don't see you taking notes. Pearl, I don't see you taking notes. Morgan, I don't see you taking notes. Okay? Now, why I'm doing this is because on Thursday, when your parents ask me why you're not passing this class, I'm going to say, look at the YouTubes. Okay? Look at the YouTubes. I do the work in front of them. I let them go home and copy it from the YouTube. And yet they still cannot get it done. And all they have to do is listen and follow along. That's it. It's not a lot. Okay.